In today's lab, we are going to see how to interface a potentiometer using ADC present in the Arduino. So this is known as a potentiometer. So potentiometer is nothing but a variable resistance, and it is having three contacts or three terminals. In that, the center terminal is the variable point. When you are turning the potentiometer, the resistance will change and the voltage output which you are getting at the center terminal will be varying based on the position of the pointer. So we are going to interface the potentiometer with the ADC present inside the Arduino board. So first of all, you can drag and drop the Arduino board to the TinkerCad. Now you can take the potentiometer, drag and drop it here, and since potentiometer is generating analog voltage, the output of the potentiometer should be sent to the analog input pins of Arduino, that is A0 to A5, right? So the analog output from the potentiometer will be connected to any one of the pins from A0 to A5, that is analog input of the Arduino, so that the analog voltage given by the potentiometer will be sent to the ADC present inside the microcontroller, and the analog voltage will be converted to digital value using the ADC. Based on the digital value, you are going to control the rate at which an LED is blinking. That is what you are going to do. So here in potentiometer, three terminals are there: terminal 1, wiper, and terminal 2. Terminal 1, I am going to connect it to VCC or 5 volt. Terminal 2, I am connecting it to ground. This is a ground. The sender terminal or the variable terminal, I am going to connect it to A0. For time being, I am going to change the color of the wiper to say red color so that I can identify that. So whenever I am turning the potentiometer is acting like a voltage divider, and the voltage output present in this sender terminal will be changing. So if you are keeping at this position, the voltage value will be say low, and if you are turning it to the other position, the voltage generated will be high. This low voltage or high voltage will be generated based on the ground and VCC connection which is connected across terminal 1 and terminal 2, right? So next I am going to connect the LED. I am using the same LED which is onboard LED connected to pin number 13. In addition to that, for time being, I am going to connect an external LED also to the same pin so that I can easily see it. So this is LED. So two terminals are there. One is known as cathode, another one is known as anode. The cathode I am connecting directly to ground pin. To the anode I am using a resistance. I need to limit the current. It is a normal 3 mm LED which operates on 10 milliamps. So I need to have a current limiting resistance. Why? Because the Arduino can generate 25 milliamps, but your LED require only 10 milliamps. So in order to reduce the current from 25 to 10 milliamps, I am using the resistance, and the resistance value I am giving it as 330 ohm. 330 ohms. 330 ohms. So that 25 milliamps will be converted to 10 milliamps. You can use the calculation of Ohm's law in order to calculate it. So I am connecting pin number 13 to the resistance another end I am connecting to the LED. So this is a hardware connection. Based on the potentiometer position, the rate at which LED is blinking should change. So I am clicking on the code. This is a code, already it is generated. I am keeping it here. Now for storing the voltage value, converted voltage value or converted digital voltage value, I am using a variable. So for that you can click on the variable block, then click on this create variable, I am going to give a variable name as, say, sensor value. I am going to give a variable name as sensor value. So what I am doing, I am going to read the ADC value. That value I am going to store it into the variable known as sensor value. Then I am clicking on the input block. Here I can see a block known as read analog pin A0. So why I am using this block? The first step in this program is to read the analog voltage which is generated by the potentiometer. So I have connected the potentiometer to A0. So I need to read the analog voltage from pin A0. So I am dragging that block and keeping it here. This analog voltage value read from the A0, I need to store it in the variable I have generated before. So click on the variables. Here you can see a block known as set sensor value to 0 or change sensor value by 0. Drag and drop this block, set sensor value to 0, right? So here what I am doing is, instead of 0 I am dragging and dropping it here. So what will happen? The sensor value variable will contain the ADC value read from A0. So set sensor value to read analog pin A0 means, first of all, A0 value, analog value will be read from analog pin 0. It is nothing but a digital value. Whatever analog signal you are giving to A0, that will be converted to a digital data. That digital data will be read by using this read analog pin A0. That digital data I am going to store it in a sensor value, right? Now what I am going to do is, I am going to take the same block and keeping it here. Instead of blinking the LED in 1 second delay, I am going to use this sensor value here, right? So how will I do that? Drag and drop the sensor value to the wait block. So wait for sensor value. Instead of second, I am taking it as millisecond, right? So first of all, the ADC value will be read by the ADC. Corresponding digital value will be generated. That digital value is sent to the sensor value variable. Then you are making the built-in LED on. Built-in LED means this LED will be on, onboard LED will be on. In addition to that, this external LED also will be on. Then you are telling the controller to wait for these many milliseconds. How much millisecond? Based on the value stored in sensor value. Similarly, I am making the LED, built-in LED off and the external LED off, because both I have connected to pin number 13. Then again I am going to give a same delay as I have given before. That is, wait for sensor value, wait for the value stored in sensor value variable, that many milliseconds, right? So this program I am going to simulate. So run the simulation. So now you can see that the LED is switching on in a slower rate. When I am increasing this, the speed of the LED blinking is changing. You can see here, right? Now it is blinking at a faster rate, much faster rate. Why? Because when I am increasing, when I am turning the potentiometer towards this side, the analog voltage generated at this point is getting reduced. So the delay time between on and off is getting reduced. When you are turning to the other side, you are getting a larger value as a digital data from the converter analog input. So the LED is blinking at a slower rate. So this is how you are interfacing a potentiometer with the ADC present inside the controller, and based on the ADC value, you are controlling the rate at which LED is blinking.